Assalamualaikum and hello, my name is Nurul Anshada and with my fellow group members Siti Norosmawati, Nur Hamiza, Nur Fatiha Huda and Nick Amalin Aisyah from Group 5 will presenting about modeling and dynamics of asset price and Monte Carlo simulation. With that, I would like to pass to Nur Hamiza to start our presentation.
Assalamualaikum. I will present about basic financial asset. A financial asset can be defined as a liquid asset that gets its value from a contractual right or ownership claim. For example, cash, stocks, bonds, mutual funds, and bank deposits. Stocks are financial assets with no set ending or expiration date. For example, an investor buying stocks become part owner of a company and shares in its profits and losses. Bonds are one way that companies or government finance short-term projects. The bondholder is the lender, and the bonds state how much money is owed, the interest rate being paid, and the bond's maturity date. Derivative is an instrument or contract between two parties that derive its value from the value of underlying asset variables. The most common derivatives are forward or future contracts and options. The major users of derivatives contract are hedgers, speculators, and arbitrageurs. Hedgers use derivatives to reduce risk from potential movement in the market variables, while speculators use derivatives to bet on the future direction of market variables. Arbitrageurs take an offsetting position in two or more instruments to lock in riskless profit, which buy at low price, sell at high price. In theory, prices are the consequences of an equilibrium between the supply and demand of an asset. Fixed income securities are a type of debt instrument or investment that provides return in the form of regular or fixed interest payments and principal repayments when the security matures. And governments and corporations typically issue these income securities to fund their activities. For example, fixed coupon and zero coupons bonds. Low is the formula of rate of return on investment, which is R equal to W1 minus W0 divided with W0, where W0 is equal to initial wealth and W1 is equal to wealth after invest 1 year. Next, for simple interest rule used to calculate the amount of interest charged on a total original principal amount. Interest is used at a specified rate for a given period. The formula is I equal to PRT. At the end of investment, to sum the principal and original amount with interest, we use formula WT is equal to W0 open bracket 1 plus RT close bracket, where W0 is initial wealth, or it can be said as an original principal amount. WT is wealth at time t, R is interest rate over the time period, and T is time in years. Next, we use compound interest to accumulate the amount of interest of the next year by adding the interest of previous year to the principal. We use formula WT equal to W0 open bracket 1 plus R over M close bracket power of MT, where W0 is initial wealth, WT is wealth at time t, R is annual interest rate over the time period, M is compounded times per year, and T is number of years. Next, present value can be used to calculate the current value of an amount of money or a stream of cash flow. We can use the formula below to calculate the discrete compounded present value, which is PV equal to summation of K is equal to 0 and CK over open bracket 1 plus R over M close bracket power of K, where CK is a cash flow at K, M is payments per year at regular time intervals, K is time periods, N is number of periods, and R is interest rate. Continuously compounded present value can be calculated by the formula below, V equal to summation of I equal to 0 and CI exponent power of negative RTI, where R equal to 1 to until N, and TI is time at which cash flow CI is received.
I will continue presenting the next part. The randomness of asset price can be predicted by using modeling and dynamic of asset price, which is beneficial for financial decision making. The asset price must be described as a stochastic process. We do apply the modeling and dynamic asset price for more complex portfolio management models. It could be discrete or continuous time model. The multiplicative model is ST plus 1 equal to UTST, where the ut is bigger than 0. The additive model st plus 1 equal to ut plus st cannot be said that ut as a non-negative value for the model price drop, as st also cannot be assured will be non-negative value. With that reason, the additive model are not reasonable comparing to the multiplicative model. To determine a plausible probability distribution for random variable ut, we consider the natural logarithm of stock price as log st plus 1 equal log st plus log ut equal log st plus zt, where zt is increment in logarithm of price and is normally distributed, so that ut is log normal. Next, let st as the initial price of stock, and unfolding the equation st plus 1 equal to utst. The equation becomes st multiplication of k equals 0 t minus 1 uk as naught, which implies that log st is log s naught plus summation of k equals 0 t minus 1 zk, where log st is normally distributed, so that the stock price is log normally distributed. By using the notation of e square bracket zt equal to v and var zt equal to sigma square, zt is used in computing variance. From the equation below, we will get e square bracket log st equal to log s naught plus vt. We can see that the expected value and the variance of increment in logarithm of the stock price scale clearly with time. In deterministic case, we have d log st equal to v dt, which need to include noise in stochastic form. So we will have the stochastic differential equation in form of d log st equal to v dt plus sigma dwt. We will integrate both sides for equation in this deterministic case over the interval 0t to obtain continuously compound stock price. Thus, the equation is integration of 0t d log st equal to v integration of 0t dt st equal to s0 multiplied with e to the power of vt. Therefore, this is how we obtain the continuous time model from discrete model. In standard linear process, in discrete time, we do consider the following process as a building block. Wt plus 1 equal to Wt plus epsilon t square root of delta t, where the epsilon t is sequence of independent standard normal variable. For k bigger than j, we can see that wk minus wj equal to summation of I equal j k minus 1 epsilon I square root of delta t. Standard linear process can be defined as continuous time stochastic process with following properties. First, W0 equal to 0 is actually a convention. Second, increment normally distribute. As example, given any time interval square bracket st, the increment Wt minus Ws distribute as n bracket 0t minus s with expected value of 0 and variance t minus s. Third, increment are stationary, as they do not depend on where the time interval is, but on their weight. Lastly, increments are independent. For example, T1 smaller than T2 smaller than T3 smaller than T4. Then WT2 minus WT1 and WT4 minus WT3 are independent random variables. Wt used as building block of stochastic differential equation. Given real constants A and B and assume that stochastic process xt satisfying the equation, we obtain dxt equal to A dt plus B dwt, where A is drift rate, which measure the mean change over period t, and B is variance rate, which measure the variance change over period t. This is generalized linear process. Next, Ito lemma, which Ito's process xt satisfied the stochastic differential equation. Ito lemma equation write as dxt equal to axt dt plus bxt dwt, which in some case the continuous limit of, where epsilon is approximate to n01. Equation will be dxt equal to axt dt plus bxt epsilon t square root of delta t. Ito lemma can be used to find solution at least in relatively simple case. Geometric Brownian motion assume the rate of return to be a constant value. Geometric Brownian motion can be defined by stochastic differential equation, which is dst equal to mu st dt plus sigma st dwt.
Next, I will present about example related to modeling and dynamic of asset price. For example 1, consider a 5 years zero coupon bond with face value 100 sold with required yield 0.08, which is percentage change in its price if the yield is increased immediately after purchase to R to 0.09. When we use MATLAB for P1, we get 68.05x3. For P2, we get 64.9931, and the answer we get 0.050. We see that we have 4.5% decrease in the value of the bond. Not that this is loss occur if you have to sell the bonds before maturity. No harm is done if you keep the bond to maturity. But this makes sense only if the liability you want to match coincide with the maturity. Now, what if the maturity is 20 rather than 5 years? When we use MATLAB, we get P1 is equal to 21.4548. For P2, we get 70.8431, and the answer we get 0.1683. For example 2, suppose that the stock price model follows the geometry Brownian motion for the st equal to 0.1 st dt plus 0.2 st dwt with initial stock price as 0 equal to 3 at the initial time t equal to 0. Write a MATLAB code using the Euler discretization with time step 1/400 to plot a path of the stock price for the time t equal to 0 to time equal to 2. When we use MATLAB, we get the graph for in the below.
For introduction Monte Carlo is a method or mathematical technique which is used to estimate the various outcome of an uncertain event. Monte Carlo method, also known as Monte Carlo experiment, which are type of computational process that use repeated random sampling to produce numerical result. Lastly, Monte Carlo method help to explain the impact of risk and uncertainty in prediction of forecasting model. Problem statement for Part B. Large investment project financed with EU fund must meet certain criteria, particularly those relating to the size of the risk, the obligation to conduct a risk analysis for investment in the framework content of the feasibility study. Aside from this clause, there is no specific technique or restriction outlining how risk connected with investment project is calculated. In this context, the current study proposed a risk estimation method which is Monte Carlo method is used on investment project in a standardized way. In conclusion, the Monte Carlo method is straightforward to use and provide useful information on the risks related to investment project. The Monte Carlo approach is simple to use and provide valuable information on the risk. For this regard, we can suggest and offer the following alternative tactic for project manager to consider, which are acceptance of risk such as tolerance, risk monitoring, and managing risk strategy. Thank you.